Hello everyone. So my name is Guillaume. As Cynthia said, I'm a recent colleague of her, and I will talk about a bit of my experience in the past in what I could view in my previous experience as a network engineer in another company. So here we start. So I don't really have a plan in that presentation. There is a global structure, but as the Joker would say, I'm not a guy with a plan. I like to go with the flow of the presentation. So we'll do just that in a few minutes. So I'm a network engineer for 6 years now, almost 7 years. I'm working for the Restena Foundation since about 2 months, almost 3, to work on the Restena network, on the LUNOG3 network as well, and on the DDoS platform, which is being built for the state of Luxembourg. So I'm mostly interested in network, of course, and code as well. And you can find some of my contributions on the internet, on GitHub mostly, about peering manager and the looking glass, where you'll find some maybe tools that would be useful to you. So if that's okay, go ahead to GitHub and check for it. So when I started my job, doing my job a few years ago, I just get out of the school in France, where I was graduated with a network engineer degree. And basically, when you go into the field and start to do the work of an engineer, you know that you know nothing. So I came in a network environment, which was a carrier network mostly, doing network service provider related work. So you have to go up to speed, and you have some reality check, like internet is driven by money and not by ideas. Of course, there are some ideas, but in the end, the money is leading where you go with it. So this was the first reality check for me, because I'm mostly a geek. So I like doing technical stuff. I like doing proper technical stuff. And when you have the money as a metric of the internet and how you are going to build your network, this is a constraint that you not have in mind, that you don't have in mind all the time when you're freshly graduated. So the first things to get to work is to be humble, you don't know everything, you never will. There are always experts in some domains that are better than you, and you can try to get to their levels. You may get to the level, but there is always someone who is going to be better than you in the end. So the goal for you as a network engineer is to keep learning again and again and again. So in the beginning, I'm arriving in a network. The network is quite small, a few routers, nothing fancy. It's MPLS based, mostly with Juniper devices, and some switches are actually being used as routers, mostly due to the financial part, because switches are much cheaper than the actual router and have a lot of ports compared to a router. So this is when you find that the money is going to do a lot of things for you, but also get you away from a lot of things. So I'm arriving in the network. There is some configuration backup, which is good enough, even if it's over telnet, which means it is not protected from using encryption techniques. And you're going to get some kind of view of the network using the monitoring tools that are good enough in general. If you found tools such as Observium, Isinga, Nagios, whatever, in general, you came with a monitoring system which is good enough to tell you some stuff about the network. One big issue was a security issue I found in the network. Like you have one account and one password to log into every device. The account is the same, the password is the same. You may have this in your infrastructure as well. It's not that it is bad idea, because it can be useful at the beginning, but in the end, it's a bad idea. So one of the goals was to get rid of that account, to have a user-based system to control and manage the permissions properly. When you arrive as a first network engineer and the first technical guy in a company, in general, there is some systems to take care of, and we all know that now there is a cloud with Amazon, Microsoft, Google, DigitalOcean, whatever. But most of the time, you have also server to take care of. So this was part of the job as well, and it was actually a big part of the job, because you need it. So during the first 2 years, maybe 3, basically you learn about doing your job. Actually, I'm talking about me, so I'm learning about doing my job. I'm learning some new concepts about that I didn't learn at school, of course. Some concept like ENNI and VLAN mapping operations, which is a really useful techniques for network service provider. You learn about route reflector design as well, because you end up deploying more and more devices, and the network grows. The network has to scale. So in the end, you have to use route reflector techniques or stuff like that to avoid setting up hundreds of internal BGP sessions, for instance. Of course, you have to find demarcation customer on-premise equipment for monitoring the lines you have at your customers. You have to do on-call schedule. We were 2 at the beginning, so on-call was not really defined. The first on the problem is the guy taking care of the problem. What it means is that there is no schedule, no pay in the end. So this is, let's say, a drawback you have to consider. Late night migrations are a lot of your job. You're doing a lot of migration to avoid customer impacts during working hours. So this is a lot of my nights going into data center and POPs to build them, to migrate customer services. And of course, all of this give me quite of a pain, but it was a good pain, because I learned a lot of stuff bringing to migration. In the end, you do a lot of mistakes for your first year. So, like I said, when you're doing mistakes, you suffer, but that's for your own good, because you learn from the mistakes you make. So in the end, you don't necessarily prepare your migration, and you go on the field without without any kind of things of task prepared. So the schedule of the migration is impacted. You have intensive nights, and you end up maybe having to roll back your change or stuff like that. You like proper lab because of money, because of money mostly, and you cannot test necessarily your migration before going into the field. So you have to make some assumption, and sometimes you have to pray a little bit. In your classic network, MPLS network based, you have provider equipment as router, and sometimes to accommodate your route reflector design, you need to convert some to route reflector. So it can be due to be it can be a reason due to a reason of money, of cost, because you can't dedicate hardware for route reflector work. Route reflector is basically just a router that is computing routes, but not in the ideal case is not forwarding any traffic. It's just signaling routes over the network. So you don't want to have the route reflector in the path, but in the end, sometimes you have it. And at that time, in my beginning years, we used MX104 Juniper router for route reflecting, and it was really slow, and it means that when the route reflector goes down or is too slow, this is going to impact the network. So it was a pain, and we had to make a change about it, basically. In the end, to fix some stuff, we decided to go with virtual appliances for route reflector. You learn about preparing your network migration, the also going into the OS upgrade process before going into the field and stuff. You have to go you start to monitor the forwarding issues over the link with BFD, but you have to take care of the timer, because small timers means a lot of work for a control plane of a router. You start to choose a vendor as a layer 2 demarcation for your circuit. You improve the AVM hosting system by adding nodes and stuff to give it more strength, to give it more ability to handle failures. Sorry, and in the end, you have a router. You have a backbone of routers, which is going to stabilize and stuff like that. So in the end, you can be happy with the network, but there's still some stuff to do. Of course, there is always something to do in our field, you know. And then I went through what I call a big bang, because we acquired another network after stabilizing everything, and this is where the issues gets complicated, because you don't know the network. The companies are merging, so you have to audit the network again and again and again to know what this new networks brings to yours. And of course, you have different vendors, you have different technologies. The merge process is complicated, so you need to take care of this. You need to focus on this, but you don't necessarily have the time to do it. So that's a really big challenge. So anyway, it's time for network integration of that new network, and this is where the pain is coming. It's using in my case, in my experience, it was using Cisco, Sienna, and MRV devices, and it was mostly based on a big layer 2 countrywide in Luxembourg mostly, but also some international POP as well. And you have to migrate everything from the MRV, the Sienna, and the Cisco devices to your existing network, because you want to impose your vision over that network. So you find some MPLS TP, which is not a bad implementation of MPLS, but it was different from the one I had in production in my previous network. You have some Cisco on the border on their switches, and we mostly had Juniper devices, so there is syntax, of course, issues you will find, and you need to merge all of that. And this is where the fun begins, because data center has to be destroyed, and this was the BC data center, which has been demolished and rebuilt in the RTL city campus. So everything needs to be taken care of. You have to move everything from one data center to another, but there is a lot of stuff, there is a lot of services, and basically this is war this is war. You have to do everything, and you have Juniper QFXs to do that, but in the end they're shitty, and they cannot help you to do that. So that's a big issue, and you have to go through lots of technical issues and human issues as well. Basically, QFX are no good for MPLS network. You have to migrate and remigrate again, because you have to get rid of them to replace them with MXs. The customer are complaining about the service going down constantly. The guys who are doing on-call shift never sleeps. The network engineer never sleeps either, or they're sleeping in the office, and that's for real, I mean. And you are under stress constantly, and the network is totally broken, but you have to go through it. So you have to rely on your team and to get that over with, and go ahead with your life, because you don't have anymore. So we identified other piece of hardware to fix the issues for good, and it was mostly with Juniper X4550, and issue with QNQ with MEF not compliant devices, not transparent to layer 2 protocols. We saw loops inside customer networks because we started to deploy MEF compliant services, but of course the customer doesn't believe you, and that's an issue. So you have to explain and explain and explain again why their network is failing. It's because you just do what you actually sell them. So this is a big part of the work, actually talking to the customer as well, and helping them through the migration you're forcing them into. In the end, you managed to get through it. The technical side got fixed, but the human resources side is a bit more tricky. Some guys burned out. Some guys resigned, and sadly, the company is not always here for you, and you have to do whatever you do whatever you can to get your head back in the track. So will I do it again? For me, I'm ready to do anything, but going through that kind of hell again, that's not for me anymore. I'm too old for that stuff, you know. And basically, after so all of this work, you have to move on. You have to continue the migration to acquire the network. You have to deploy some POP. You have to sleep. You have to have a life to avoid getting through another breakdown on your end. And you have some day-to-day job to go through. And then another big project comes up, and you have to migrate another DC rooms, another bunch of DC rooms. But sadly, I was not part of it for health reasons. So congrats to my fellow colleagues that did that without me, because they've gone through a lot again, sadly. Well, after that, you're back into production. You're going through layer 2. You're going to production with internet access, layer 2 VPN, POPs. The number of router grows 30, 40, 60. You have up to 70 routers. So you have to automate boring tasks with deploying, for example, LSPs over your network. You find out that, what a surprise, you don't have a proper information system, so you don't have any details about what to do and where and during which timeline. And sadly, that's required to do automation. So you have to set up tools and stuff to go into the automation. And mostly you use open source tools because, of course, the money is still an inconvenient stuff. So you have to find free tools. Open source is not the meaning of free, of course. I know that for a fact, but some of the tools are free, like Netbox, like Peering Manager for my tools. You Snipe IT for inventorying. You can do whatever tool suits you, but you need them. And otherwise, this is going to be a slow and painful path for a long time. But if you adopt them, this is going to be slow and painful, but for less time. But people need to get used to that kind of tools, of course. So there are processes to implement. In the end, some cool projects reappeared, of course, like the POP design, the cost per effectiveness with MX204 and QFX 51 and 10. So I'm not going into detail with that because it's a bit complicated, especially if you don't have any experience with Juniper devices. And we also decided to separate the full routing table from all the router to put that into a ring of router dedicated to the internet traffic, and to better cope with DDoS and avoid DDoS to crash the entire MPLS network. And that's a big step. Mistakes were made, of course, not choosing MEF compliant devices, trusting one vendor, which was Juniper at that time, and not testing the device properly. Virtualizing key point of the network infrastructure is not always a good reason, because you might find some issues with that. You take too many time to decide which CP you use or not. The lack of information system is a big drawback for your day-to-day job, like I said previously. And the biggest drawback you have is probably having a lack of developers, because a developer is quite interesting to have in your team to develop homemade tools. So in the end, we decided to use only MEF compliant devices to solve the MEF compliant part. We decided to stop trusting vendors and stuff like this, and go ahead. So, and I already ran out of time, so I'm going to be a bit faster now to conclude. And key point to scale: don't get attached to your network. Migrate, and migrate again. Don't have fear of the mistakes. You don't have to ignore them. This will kill you. And be modest, trust your engineer, trust yourself, but reassess yourself also as well. And basically, to conclude from a technical point of view, layer 2 is nasty. We all know that. If you don't know that, you have to learn it. You don't extend layer 2. Extend layer 2 is a bad decision. You have to choose the right vendor for the right use case. Do not over-engineer your system infrastructure, especially if it's not your job, because this is going to be painful later. Keep it as simple as possible for simple debugging. If your world network is down, you don't care about the system infrastructure being down. Automates repetitive tasks, network, keep it up to date. Don't be afraid to break stuff, and so on. We all know the drill. And as a last point, I would like to thank the guys from that slide who have a terrible side, but that's on purpose, for their continuous support and for working with them. That was a really nice ride with them, and I would like to thank them. So I'm out of time, and by quite a lot, so I'm going to stop here. Thank you for listening, and if you want to talk, feel free to reach me.